Yeah, I mean, if everyone's happy for me to get going, I suppose I'll just start talking. It's going to be weird looking at my screen and not seeing people's faces, but here in the metaverse or whatever.
Should be able to see the people's faces.
Yep, I can see now. Awesome.
Okay.
Yeah, so I suppose we're going to do a little bit of a change of pace, I guess. Stop talking about public key crypto and start talking about symmetric encryption. So I'm going to talk all about this interesting concept called envelope encryption that I looked into a lot over the last couple of months. So I suppose you're all probably wondering who I am. My name is Bennett. I'm streaming live at the moment from Mackay, North Queensland, down to Sydney. From sunny Mackay. It's nice and warm up here, but I've got the aircon on really cold to try and simulate being down there in Sydney. My professional background is mainly a lot of web development stuff. I've built so many front-end applications you wouldn't believe, but I recently had a bit of a career change and started working at this company called CipherStash, which you might have heard of. We make a searchable encrypted database. It's lots of fun, lots of encryption stuff. So in the weeds with the encryption stuff now. I'm pretty much an expert, I'd say, the authority on encryption. And my academic background is I studied computer science at QUT, did mathematics and information security. So if you have any doubts in your mind about how much of an expert on envelope encryption I'm going to be, rest assured. I've got all the merits that you need. Except, and this is the kicker, I actually failed all my cryptography courses at university. But actually, that's not completely true. I dropped my university courses on cryptography because I failed the first exam and I didn't want it on my academic record. So yeah, unfortunately, I'm a fraud. I'm not the cryptography expert that you're probably hoping for to talk to you about envelope encryption. So I'm sorry, this is not about envelope encryption. Well, it kind of is. It's just a different perspective. It's a newbie's dive into envelope encryption. It's my trials and tribulations, I suppose, as I was diving into this very foreign world for me as someone who tried to do encryption once upon a time and failed miserably. And the subtext here is how I learned to stop worrying and love acronyms, because if you're reading the AWS docs, you're going to be reading a lot of acronyms. So here we go. Enjoy. Chapter 1, why? Now, you may be thinking this is the why would you use envelope encryption, but no, it's actually why am I being forced to learn about envelope encryption, or not being forced, I suppose. It's a bit happier than that. But what I mentioned before, CipherStash makes a searchable encrypted database or encrypted search index, a whole bunch of things nowadays. And there's lots of encrypted cryptography stuff going on in there. A lot of stuff that I don't understand. The searchable side is pretty far out of my depth, but the other side, the encrypted database side, it's more manageable. It uses lots of off-the-shelf kind of stuff. Which is cool for me, someone who likes to read docs. At the moment, we have client libraries inside JavaScript and Ruby, but when I first started, it was only in JavaScript. And at that time, the encryption library, I suppose, that we were encrypting all of the records inside the database with was the AWS encryption SDK and the AWS key management service. So this is the first lot of acronyms. It's AWS ESDK plus AWS KMS. Right? Rattle that one off a couple of times. So we're using this very specific client, this very specific SDK to JavaScript. And when we're thinking about adding like more client libraries, or I've got this line here, we really wanted more client libraries. A certain language might not have like the good AWS SDK. It may not have good bindings for all of that stuff. And so we really wanted some kind of like flexible encryption solution, I suppose, for encrypting the records. And so here's the next acronym. We decided to RIIR, which in internet speak, if you haven't heard about it, is rewrite it in Rust. So we decided to make, or I suppose Dan decided, or a lot of people at CipherStash decided to to create an envelope encryption library inside Rust, which we've named Envelopers. And then after Dan had kind of been working on that for a bit, he handed it over to me. And you might be wondering, why didn't we do it in C or C++ or Zig or Go or insert language here? There's a lot of them. I don't know. We just like Rust, I suppose. I like Rust. It's also got good like correctness and memory safety guarantees and stuff. And I heard that buffer overruns and stuff like that are really bad for security. So yeah, gotta love Rust. Chapter 2, what? So this is what I was sort of asking myself when I started looking into this. What even is envelope encryption? And so as you can probably imagine, as most do, I suppose, I immediately hit the textbooks. I was going to the library. I was doing all that kind of interesting stuff. No, what am I kidding? I Googled envelope encryption, and this is what came up. So let me read that one out for you. Envelope encryption is the practice of encrypting plain text data with a data key and then encrypting the data key under another key. It's the first line from the AWS docs. And if you know about envelope encryption, you probably think that's a very succinct and good definition of it. But for someone who knows nothing about it, this just confused me even more. I only saw one mention of envelope there. I thought there'd be like 3 or more. And there's all these mentions of data keys. So when I asked what is envelope encryption, it's just this whole bunch of stuff with data keys. But as I like to do, I started to dive into the code. I looked around through the stuff that we're already doing. And it turns out that it's actually some kind of black magic, at least to me at the time, that was happening behind the scenes inside the AWS encryption SDK. So we were using the AWS encryption SDK in our JavaScript client library. And so we're kind of using envelope encryption, I suppose, all along. And the most, I suppose, succinct example of this, without even realizing that you're doing envelope encryption, is when you go to the AWS encryption SDK JavaScript client library GitHub page and look at the example called KMS_simple. So I've brought up the example here. You start off by creating a key ring, and here it uses this KMS keyring node, but there's a whole bunch of other ways to generate keys and whatnot. Lots of internal AWS encryption SDK stuff. You then ask the keyring to encrypt some data for you. You get an encrypted result. And then you ask it to decrypt it for you, and you get a decrypted result. And so if you're ever doing any kind of encryption or decryption or application level encryption stuff inside your cloud or inside AWS, you might even be using envelope encryption without even knowing about it. So to dive a little bit more into what's actually happening under the hood here, I suppose we'll go into the next chapter, which is the life of a plain text. So let's talk about that encryption part that's happening in the example. So when I call the encryption method on the AWS encryption SDK, I'm not sure you can see my mouse showing up here. Probably not. You can?
Yeah.
Sweet. Yeah, so the AWS encryption SDK tries to send a message to the AWS cloud. And I've got this section here, which is the customer master key, which is like just a key that exists inside your KMS account or AWS KMS account or workspace or whatever. I've got a picture of a key ring because you can have more than one key, but I'm just going to talk about this green key as if it's the customer master key. I should also note the AWS has recently changed all their terminology. They're not calling the customer master key the customer master key anymore. They're now just calling it an AWS KMS key, but all the code examples call it a CMK. So I'm going to stick with that for a bit. Anyway, so in that encrypt method that the KMS simple example was doing, it starts out under the hood by sending a message to AWS. It says, hey, I'd really like to encrypt something. And AWS responds saying, no worries, fam. Here's a key to encrypt your data with. To help you out, I've also included the same key, except I've encrypted this key. And so if you have a look at these 2 keys here, you can see one of them is the data key, this little yellow key here, which is the data key that was mentioned on the docs before. And then there's this other key. So it's called the encrypted data key. Actually depends who you ask. AWS calls it the encrypted data key, but Google Cloud, KMS calls it the wrapped data key or the wrapped data encryption key. There's a bunch of different names, but I'll call it the encrypted data key. And so this data key is like a normal, I suppose, AES key. And then this encrypted data key is that same AES key, but it's encrypted by the master key inside your KMS account. And so then what you do is you do your normal encryption that you'd normally do. So you take the key that you were given, the plain text key, plain text data key, and you apply that to your example text. It's a bit more complicated than that, but you get ciphertext out, and then you combine it with the encrypted data key, and you create this thing, maybe, which is called an encrypted record, and then you'll insert that into the database. So the database will have like the encrypted ciphertext of your original message, and then it'll also have the encrypted data key just sitting next to it of the key that you use to encrypt that data. And so this is actually envelope encryption. So I've got this little meme here for you. This is my realization. Wait, the KMS client libraries, it's been doing envelope encryption all along. So I thought I'd try and revise the definition that was originally posed. So encrypting, so instead of the stuff about data keys, it's encrypting plain text data with a unique key and then storing the encrypted version of that key alongside the data so that the key and the data can be decrypted, which is, not as wordsmithy as the original one was, but I think it makes it a lot clearer to me anyway. The second part of the story, I suppose, is the decryption. So if you have an encrypted record or encrypted result or something like that, you'll start to decrypt it by saying, hey, hey KMS, or hey AWS, I found this encrypted data key. Can you please help me decrypt something? It'll be like, yeah, no worries. Here's the decrypted data key back. And then just normal AES decryption, you can get back your example text. So this is what it's like to encrypt something, and then pretty much very similar approach to decrypt it and get it back. And at least to my understanding, well, I mean, this is me. Finally, I understand what's going on. But this is my understanding. So if there's anyone who's actually an expert in envelope encryption, there's any technicalities that I've left out or said wrong, please correct me either now or feel free to correct me at the end. But to my understanding, finally I understand, that's how it works. So chapter 4, the why. This is the actual why now. So now that I kind of understand why, how, I suppose, envelope encryption works, I can kind of reason about why we'd want to do it. So why would you use envelope encryption? So the first thing is it makes key management really easy, or easier, I suppose. So I suppose the alternative option is to have like a customer master key or a single key or something like that, and you'll be sharing that around with any party that wants to encrypt some stuff. And then you might have like 10 copies of the key, 20 copies of the key, or a copy per node or something like that. And it gets really disgusting. So the benefit of envelope encryption, generating these data keys or getting these data keys from KMS and storing the encrypted version beside them, is you don't need to try and securely share one key, because that's just it's not gonna work out for you. The other thing is it reduces the surface area of an exposure. If you lose your customer master key, that's pretty terrible. If anyone got that, they could essentially decrypt all of your data. Like if someone gets a plain text data key, that's not as bad, because there might be like 10 records or 20 records or 100 records that can actually be decrypted by that data key. So yeah, it's not as bad. I'm not sure what the actual practices are, if there's like if there's a key exposed or data exposed or something like that. But if you need to roll keys, you don't have to encrypt your entire database again. You only have to encrypt the records or the data that was leaked or exposed. I'm gonna leave that to the information security professionals to decide the best way to manage that kind of thing. But it's definitely a tool that you can use. And at least with KMS, AWS KMS, sorry, I'm not sure about Google Cloud KMS. You can't even touch the CMK. You can't download the original customer master key. So you have no way at all of being able to decrypt data keys or decrypt the encrypted data keys without actually going through KMS. And that's, well, I mean, maybe there's arguments against it, but it's normally, it sounds pretty great, because it means you can't, risk losing all of your data in one go, at least not without going through AWS. Yeah, a noob like me thought a lot about public key crypto, and I suppose it kind of goes into this a little bit. So like, why wouldn't you just use public key crypto? There's lots of reasons with the post-quantum stuff. That's one. Another thing is that public key crypto is really, really slow, and it only makes the encryption safe. So the decryption, still, you only have one key to decrypt everything. And I'm sure there's like different key sharing methods and stuff like that, but it's just, yeah, it's not particularly safe, and it's really slow. And yeah, not quantum safe yet, but that was the talk before. Since we're kind of going down the public key like sidetrack, I suppose I'd talk a little bit about hybrid encryption, just because it's something that I kind of learned about when I was learning about envelope encryption. And this is the concept of encrypting a symmetric key with an asymmetric key, like someone's public key, and sending them that symmetric key so that you can, talk through symmetric keys. I suppose it's very similar to envelope encryption in that you're encrypting a key and then, being able to decrypt it. But the reason to do hybrid encryption is purely performance. And I think Dan mentioned like elliptic curve crypto. There's like a thing called elliptic curve Diffie-Hellman key exchange, which is the encryption that TLS uses under the hood. So whenever you're connecting to a website, you do the key exchange with public keys or with some other method. But then after that's established, you're actually talking through symmetric encryption. So yeah, that's why you'd want to do hybrid encryption. Bringing it kind of back to the meta element, I suppose, getting to the end of this. Encryption is really hard, especially for a beginner, but it is digestible if you break it down. When I first started looking into envelope encryption, the just what it's called and the way people talk about it and that kind of stuff, it made it seem like it was a very research heavy feel, like there was some kind of homomorphic encryption going on or something like that. I was a little bit spooked by it, but after looking into implementations and seeing how it's actually done, it was a lot clearer. So if you can break it down into digestible chunks, I think it helps a lot to learn about encryption. And yeah, I think it's really good to have a mentor that can help you, especially with the finer details of the implementation, because there's lots of details you can screw up. There are so many different attacks that can happen, so many different implications to not zeroing keys out and that kind of stuff. So yeah, very glad that there's lots of people at CipherStash that can tell me what I'm doing wrong when I blindly implement something. And I saw this tweet on Twitter from Dan the other day, which is please, if you're not a cryptography expert, don't write your own encryption libraries. And I wasn't a cryptography expert. I'm still not a cryptography expert. I'm not even close. But with the help of other people at CipherStash, I managed to contribute to and help write some part of an encryption library. So I thought that was pretty good. That's it pretty much about my journey into envelope encryption and the trials and tribulations, I suppose. Does anybody have any questions at all, or does anyone want to correct me on anything?
But I've got one question. So Is my understanding correct that for envelope encryption, you can use, so it is just a high level concept where you can use any type of algorithms actually?
I thought I was on mute. Yeah, probably. I looked at the KMS docs because I was wondering if there was a way that you could do it, or at least that they had for doing asymmetric cryptography, and I didn't see anything in my little perusal at least. But yeah, it might be the case. I know Dan or anyone in the audience if you have an answer.
Yeah, so it is the alternative for the scheme, like for the distribution, right? Sorry, for the scheme, it does not link to the particular algorithm.
Yeah. So yeah, envelope encryption as
any algorithm really.
Yeah, it's just a concept, but in practice, I'm not sure what the clouds let you do.
Yeah, and benefits of that, it just, if you're using, for example, so benefits came up, depends on what is the application. So if you're using in the database, for example, whereas performance will be number one, priority, then it will be faster than just any other type of the process.
Symmetric only makes sense for us because performance is such a huge consideration. And then if you were to use envelope encryption and say the data key was a public key, like an RSA key, 2048-bit, like then the data key size is going to be really big as well. So then storage is a consideration. We use it essentially as a replacement for an HSM. So you would normally have like a hardware security module. It does the encryption inside the HSM. This is kind of like the poor person's HSM in a way.
Oh, cool.
Yeah.
Oh, cool. And for example, Azure Vault, are they using the similar concept?
Yeah, actually, all three major cloud providers provide the same sort of functionality. Yeah. So there's Azure Key Vault, Google KMS, and AWS KMS.
Thank you.
Sorry, Bennett.
No, it's all good. Yeah.
You are basically tied to this cloud because you cannot get the key from the cloud.
We're not tied to the cloud. We're not tied to the cloud as a provider. But once you've defined,
if you select and create the key in this cloud, then
that's right. Yeah. You can go and re-encrypt it with another key. Yes, that's the process. Yeah.
So, and if the high-level key is compromised, what is the process?
So you would have to re-encrypt all the data keys if it was compromised.
Okay.
But the good thing about doing it with data keys is that there's an expansion, right? So let's say you've got a data key is used to encrypt 100 ciphertexts. You now only need to re-encrypt 1/100th of the amount of data. You only need to re-encrypt the data keys. You don't have to re-encrypt the plaintext. So you can kind of respond to, like, you've got a critical.
And whose responsibility, like, to track these things, whether the master is compromised or not? Like, how does it work?
It depends on the circumstance. We actually don't have it, like a SciStash, we don't have any control over the key. It's in the.
But they will have expiration date, so it's not only for the case like this scenario of the changing the key will be not if they compromise.
Just so there's an exfiltrated key, compromised key versus just routine rotation, right? So KMS and like all the key management providers do all that automatic rotation for you. You don't have to think about it.
Oh, cool.
They just generate a new one, and then all new ciphertexts are encrypted using the key. So we don't really have to do that very much. The key provider manages it for us.
Oh, that's nice.
I feel like this is asking me all questions. Has anyone got any more questions?
Maybe one more. I don't know who. But
you keep it on the track.
So basically, because I understand that this is in this use case of the database. So when do you do this decryption of this wrapped key? Like, is it like per transaction? Is it like per session? Is it per?
Want to try that now?
Yeah, I mean it depends. Like if you just use the normal, this is talking about the AWS implementation now. If you just use the AWS KMS keyring node, it'll decrypt it every single request that you make to decrypt the data. But there's like caching mechanisms and such in place that can be used. Like I'm not sure what the actual numbers are for us, but it might be that every like we might store the top 100 keys for decryption or something like that. It's just a space thing. And then any key that's not inside the cache, that it'll go and fetch. So it's kind of a mixture of both, I suppose. But there's no reason that you can't cache the decrypted data keys. Does that answer your question? Maybe Dan wants to have a go as well.
I think and that's a big part of it. I think the other part of it is typically it's done on a request. So you go and request a bunch of records from the database through some query. And then when you're ready to view those records, which is usually at the same time, you'll need to decrypt them. But as Bennett said, you can cache the data keys. You know, it's all about managing the scope of the attack. You know, cache them for a short amount of time. It's a trade-off. Yeah. Great questions. And well done, Bennett.
Thanks. Yeah, this I should really say this is like 2 months or 3 months or something like that of encryption experience. So definitely being thrown into the deep end with this talk. So there's probably a couple of things that are a little bit off, but I think mostly there.